Verify the given linear approximation at a equals 0. Then determine the value of x for which the linear approximation is accurate to within 1/10. Here we can see that f is 1 plus x to the negative 3. So f prime is negative 3 1 plus x to the negative 4 power. Up next, we can evaluate f at 0. F of 0 is 1, and we can evaluate f prime at 0. F prime at 0 is negative 3. Using those, we can plug them into the equation for the linearization, which again is f of a plus f prime of a times x minus a. Now plugging in 0, we get f of 0 plus f prime of 0 times x minus 0. That means L is f of 0, which we found to be 1, plus f prime of 0, which we found to be negative 3, times x minus 0. Simplifying this, we get that L of x is equal to 1 minus 3x. So now we've confirmed that the original f is approximately equal to the linearization 1 minus 3x. Up next, we want to determine the values of x for which the linear approximation is accurate to within 0.1. That means we want the distance between these two, f and our linear approximation, to be less than 0.1. So we have the absolute value of f, 1 plus x to the negative third, minus L, 1 minus 3x, to be less than 0.1. The distance is less than 1/10. From here, we will rewrite this absolute value inequality as a compound inequality. Negative 0.1 is less than, here we will just copy the inside of the bars, and once we have our compound inequality, our goal is to isolate the linear approximation, that L of x. So we need to remove f by subtracting it. Negative 0.1 minus 1 plus x to the negative third is less than negative 1 minus 3x is less than 0.1 minus 1 plus x to the negative third. From here, we need to divide by negative 1 to get L by itself. That's going to change all the signs of every term. It will also change the direction of the inequality. And finally, we want to rewrite this so that the smaller numbers are on the left, meaning we need to change the direction of our inequalities. So no math here, we're just rewriting it in the reverse order. So negative 0.1 plus 1 plus x to the negative third is less than 1 minus 3x is less than 0.1 plus 1 plus x to the negative third. Once we have L in the middle, we're going to go to the calculator. In L1, we will type in the left side of the inequality. In L2, we'll type in the middle. And L3, we'll type in the right side. Up next, we'll hit graph. And keep in mind what we're looking for. We are looking for where we are accurate to within 0.1. So the linear approximation is this red graph, and it looks like it's intersecting the f function around this area. So we want to zoom into that. There's a couple ways to do that. I like to use zoom box, zoom number 1. And we can draw our box. So I'm going to move the cursor to around here. Again, you just get close to the left corner of where you want your box to be and hit enter. Then we'll use the cursors to draw the rest of the box, the window that we're zooming into. Again, you don't have to be exactly the same as mine. And hit enter. And we'll see something like this. And we can do that again if you want. We can zoom in some more if you want to zoom even better. Zoom box. Again, we'll start anywhere you want. Make sure you get the corner of your box that's going to make your graph visible. Hit enter. And then we'll draw up and to the right. Just want to make sure we see all of the intersections. Hit enter and we'll zoom in and get a bit better picture. So again, we are going to be accurate within 0.1. It looks like between these two values where the two graphs are intersecting, the linear red and the blue f. To find those, second, trace, that'll take us to the calculate option, and we want number 5 where they intersect. So I'm just going to scroll till I get close to the first intersection. Hit enter. It's going to automatically jump to the next curve. Make sure it does jump to the red curve. Hit enter again. Enter one more time to guess. And it looks like X is roughly negative 0.116. We'll do that again. Second trace, number 5. This time we want to scroll close to the other intersection. So just get close and hit enter. It should automatically jump to the next curve. Make sure it does jump to the red linear graph. We do not want it to hit the black. Enter one more time. Enter to guess. And in this case, we get that X is approximately 0.144. So to answer the question, what are the X values for which the linear approximation is accurate to within 1/10? That is between 0.116 and 0.144, roughly. Again, we are estimating a little bit.